The sum and difference formulas for tangent are as follows. The tangent of alpha plus beta is equal to the tangent of alpha plus the tangent of beta. Notice that those two signs are the same, all over 1 minus the product of the tangent of alpha and the tangent of beta. And that sign has changed. So if I have a plus here, I'm going to have a plus here, but I'm going to have a minus down here. And the relation to the difference formula is that they are the same, except where there was a plus here in this formula, I'm going to have a minus in this formula. And where there was a minus, I'm going to have a plus. So this is going to be the tangent of alpha minus the tangent of beta all over 1 plus the tangent of alpha times the tangent of beta. And these are more formulas that you need to have either memorized or written on a card for easy access. So far we have the sum and difference formulas for sine, for cosine, and for tangent. That's 6 different formulas. I would argue you really only need 3 of them, because if you're looking for the difference, the tangent of a difference of angles, you only need this formula, and then when you use it, you change all of the signs. Where there was a plus, you put a minus. Where there was a minus, you put a plus, and you have this formula. So one way to write that, for example, would be that instead of writing both of these, you could write the tangent of alpha plus or minus beta is equal to the tangent of alpha plus or minus the tangent of beta over 1, I'm going to leave that for a second, the product of the tangent of alpha times the tangent of beta. Because the formulas are otherwise identical, right? Tangent of alpha, tangent of alpha. Tangent of beta, tangent of beta. 1, 1. The product of tangent of alpha, tangent of beta. So the only difference is the signs. Now, the reason I left this one blank is that many people don't know that there is actually a sign minus or plus. And it's important to note that that's different from plus or minus, because here, if I want the sum formula, I'm going to go tangent of alpha plus beta. I'm going to go across the top. Tangent of alpha plus tangent of beta. But since I'm going across the top, I have to go 1 minus the product of tangents. If I want the difference formula, I'm going to go down through the bottom. Alpha minus beta. Tangent alpha minus tangent beta. But down here, I'm going to go 1 plus tangent alpha, tangent beta. So that's one way to save a lot of space on your note card. Right? You can do that with the sine, cosine, and tangent formulas. How much you use it? Well, for example, find the exact value of, right? But I know a formula for the tangent of the difference of two angles. It's this formula right here. So this can be written tangent of pi over 6 minus pi over 4 can be rewritten as the tangent of pi over 6 minus the tangent of pi over 4 all over 1 plus the tangent of pi over 6 times the tangent of pi over 4. Now in this case, these are all nice, friendly, familiar. There are only 2 angles here, pi over 6 and pi over 4. They're both in quadrant 1. Everything's positive in quadrant 1, so your arithmetic should be very simple. This is close to the example 5 in your textbook. Try it number 3 is a little bit more complicated because the angle 2 pi over 3 is in quadrant 2. So you need to consider whether the tangent of 2 pi over 3 is positive or negative when you're doing the arithmetic there. You'll need the reference angle pi over 3, and then you'll need to figure out whether tangent of an angle in quadrant 2 is positive or negative. Now, I've said that problems like this are pretty uncommon. Actually, finding the exact value of this kind of expression is fairly uncommon, but there is a way in which it's quite useful to use these sum and difference formulas. And we're going to talk about that in the next video.